Well, welcome to this continuation of our discussion about the law of signs. And not to be vague or anything, but we are going to be talking about the ambiguous case in this video. So, what the heck is the ambiguous case? Well, if you know what the word ambiguous means, it means to be kind of unclear. And that's exactly what this is. If you are given the measures of two sides and a non-included angle, well, then in order to be able to solve this triangle, we need more information because we may have some things that aren't quite clear. We don't really know if it actually makes a triangle, or does it make two triangles, or is there just one? And what we need to do is make some additional comparisons and analyze this a little further. So if you're given two sides and an angle, then one of the sides that you're going to be given will be opposite to the angle because it's not included. And then one of the sides that you're given will be adjacent to the given angle. So we're going to compare from the angle, the opposite side, to the given adjacent side. And we're also going to compare from that given angle, the opposite side, to the height of the triangle. Okay, now how do you find the height of the triangle? It's not given to you. But remember how we define the law of sines? Well, we can say that the sine of the given angle will equal the height of that triangle divided by that given adjacent side. Okay, well then I can solve for the height of the triangle by multiplying by the length of the given adjacent side and say, okay then, the given adjacent side times the sine of that given angle will give me the height. Now, often we just say, well, it's just b sine A. And that's true if we label the given angle, angle A, and that adjacent side, side B. But if they're labeled anything other than that, we need to be very careful. All right, so let's look at some situations, and you'll be able to see why this is called the ambiguous case, because there are so many possibilities. Okay, so let's start by looking at this one. Here is angle A, and pretend that you're given the measure of angle A, and we are given the length of side B. Okay, side B is adjacent to angle A. Okay, and we are also given the length of the side opposite angle A, and that side happens to be shorter than that adjacent side, and also shorter than the height of the triangle. If the length of the opposite side is less than the length of the adjacent side, and the length of the opposite side is less than the height of the triangle, there's no possible way to make a triangle. Look at this. Is there any way I can stretch this side and make a triangle? Well, not if this is shorter than the height. All right, so that's one possibility. The second possibility looks kind of like this. Here's that angle A again and our adjacent side B again. Here is our opposite side, side A, and here's our height. And the length of our opposite side is still shorter than the length of our adjacent side, but the length of the opposite side is exactly the same as the height. And if that's the case, we do have a triangle, and in fact, it's a right triangle. Okay, in the third case, we have something that looks like this. Here's our angle A again and our adjacent side. Here is the height of the triangle, and our opposite side is going to be shorter than the adjacent side, but longer than the height. Okay, so the opposite side is shorter than the adjacent side and longer than the height. Well, all we know about that opposite side is its length. We don't know its placement at all. And in fact, I can actually place it here on the right side of the height, or I can reflect it over the height and place it here on the left side of the height. So that means that there are two possible triangles. I have this original triangle here, and I've got this little tiny sliver triangle here. Okay, I've got a huge obtuse angle and then two small acute angles in this one. So in this case, there's two possibilities for triangles. And in our last example, we have our given angle, angle A. We've got our adjacent side, side B. We have our height. And then the last side, the opposite side to angle A, will be larger or longer than the adjacent side. If that opposite side is greater than the adjacent side, it will obviously be greater than the height. And so there is only one possible triangle. Okay, so this is why just having two sides and a non-included angle given to us is a little bit unclear, a little bit vague and ambiguous. So we need to be just very careful when we're trying to solve triangles.